All right, let's look at numbers 3, 4, and 5 from June 1998, Game 1, which is also, Prep Test 25, Game 1. So we have 3, 4, and 5 left to do, so let's get started. Number 3 says, if the only members of the planting committee are G, H, and L, and if the two committees have as many members in common as the conditions allow, which one of the following must be true? Okay, so the first thing we have to do is put G, H, and L in the planting committee. And after we do that, that's it. That's it for the planting committee, right? And now we need to make it so that the trails committee has as many members as possible in common with the planting committee as the rules will allow. So what we want to try to do, if we're trying to put as many people in there as possible, is put G, H, and L here, right? So G, H, and L all go in, okay? So now we have 3 in common. Are there any rules violated? Well, if we look at the rules, there aren't really any rules about G, H, and L, so it doesn't seem like there's any problem with putting all of them that were in the planting committee also in the trails committee. And that means they have 3 in common, and that's the maximum, obviously, that we can achieve. So now, are there any other rules that tell us we have to have anyone else in the trails committee? And we look through the rules, and the one that applies here is that M is used at least once. So we know that M is not used in the planting committee, so it's going to have to be used in the trails committee. And that's about it as far as all what we have to do. And you can double check, you look at the rules and you see that all of them are satisfied, none of them are being violated. Each committee has at least 3, yes. If F then not K, there's no F, we don't have to worry about it. If K then J, there's no K, we don't have to worry about it. We just talked about using M at least once, and then they have at least 1 in common. That was the whole basis for this question. They have 3 in common. So this is a must be true question. So, we could add other variables into the trails committee, but this right here is what must be true, okay? So we're going to leave it there. Now let's look at the answer choices. A says the trails committee and the planting committee have exactly 1 member in common. No, in fact, that cannot be true, right? If we are following their prompt, which is that we try to make the 2 committees have as many members as possible in common, then they're going to have more than 1 in common. They're going to have 3 in common. So A is not right. B says the trails committee and the planting committee have exactly 2 members in common. That's not right. Same reason as A. C says the trails committee and the planting committee have an equal number of members. No, that's not right, because we had to add M to the trails committee in order to satisfy rule number 4. So the trails committee ended up with at least 1 more member than the planting committee. So let's look at D. The trails committee has at least 1 more member than the planting committee. That's what I just said, right? And that 1 more member is M. Okay, so D is going to be our answer here. And just to be, in case you had a question about E, E says the planting committee has exactly 2 more members than the trails committee. Planting committee has exactly 2 more members. It is impossible for the planting committee to have more members than the trails committee. The planting committee is capped at 3, and we know the trails committee has at least 4. Okay, so that's number 3. And this is a question that comes up every now and then where they give you this constraint about overlap between the 2 groups. Hopefully this gives you a little bit of clarification if you needed clarification about how to handle these kinds of questions. All right, let's go to number 4. Let's take this work off. Number 4 says, if K is on both committees and L is also on both committees, and if the planting committee has exactly 3 members, which one of the following must be true? All right, so let's take it step by step. K and L are on both committees. So let's put K on both committees. Let's put L on both committees. And then it says, the other condition was that the planting committee has exactly 3 members. Okay, so we know we're going to put 1 more person on the planting committee, and not any more than that. Okay, so let's look at the planting committee for a second. Can we pick anybody we want to go extra, or is there some rule that dictates who's going to go there? And you guys are probably ahead of me on this. We have the K here, which means we have to put the J also on the planting committee, because the rule number 3, which says if K then J. So now the planting committee is full, and we know exactly who's on it. All right, and let's see about the trails committee. Do we know anything about what's going to happen there? Well, the same rule applies, right? If K then J. So we know that J is going to have to go here as well. Okay, but is there anything else? So we're kind of repeating a little bit of the analysis that we did in number 3, because just like in number 3, we're going to have to put M down somewhere, and so the M is going to go, since the planting committee is capped at 3, just like it was on number 3, we had to add the M to the trails committee. and that's what we just did. Okay. Now, are there any other rules that apply? Well, one thing we know is that F is not going to go on either committee. And that's perfectly fine, but that seems almost like an aside. And K, we talked about how rule number 3 applies. We've put it into our diagram. Number 4 we just applied. Rule number 4 we just applied, and they do have one in common. So this seems like as much as we can say must be true, and that's what the question is. It must be true. So let's look at the answers. F is on the planning committee. That's not only not a must be true answer, as I just said, it's impossible, right? We can't have F on either committee because we have K on both committees. So we skip A and B because they're both trying to put F on a committee. C says G is on the planting committee. That looks like it could be true. No, actually, sorry. Planning committee is capped at 3, so that's impossible. That cannot be true, right? Then D says M is on the planting committee. Again, the planning committee is capped, so that not only does not have to be true, in fact, it cannot be true. So what's odd about this is A, B, C, and D are all cannot be true answers. And is a must be true question. So hopefully E is the thing that must be true. It says M is on the Trails Committee, and yeah, that's what we found out, that M had to be on the Trails Committee because it could not be on the Planting Committee, but it had to be used at least once according to Rule 4. All right? I don't think that these questions are actually too difficult so far. I know some people may disagree, but from my perspective, this is a doable game so far. You just had to get past the structural stuff in the front, make sure you didn't mess that up, and by structural stuff I meant the fact that we don't know how many are going to be in each group, and we don't know how many times each variable is going to be used. All right, so let's look at number 5. The largest number of members that the Planting Committee and the Trails Committee could have in common is. So just like in number 3, they want us to maximize the number that the 2 committees have in common. But unlike number 3, they're not giving us anything else to go off of. So they're just saying, look, all we want you to do is maximize within the rules, and how many can you have in common between the 2? Okay, so the first try might be 7, right? Because that's the maximum that could possibly be in common since there are only 7 variables. So could we put F, G, H, J, K, L, and M all in P, and then repeat that and put them all in T, in which case there would be 7 in common? A lot of you guys are probably saying, well, no, that's not possible. And the reason it's not possible is because of rule number 2. F and K cannot go together. So we can't have all 7 variables in one committee because of rule number 2. So the maximum that we could reach in any one committee is going to be 6. I don't know why I said 3. 6. The maximum that we'll be able to get to is 6. So because F and K can't be together. So we can either put the F in and leave the K out, or we can put the K in and leave the F out. Otherwise, it looks like there's no rules that would prevent us from putting 6 together, right? There's a rule that says we can't put 7 together, but there's no rule, as long as we leave one of the F or K out, no further rule makes us go down further in terms of the number. We can put 6 on each side. So what is the maximum that they could have in common? I would say 6, because we could put 6 in the planting and then take the same 6 and put them in the Trails Committee, and the other guy, it's going to be one of F or K, leave them out entirely, okay? And so the answer here should be D, all right? So I think you get the idea that I think the big point of this game is that we didn't know how many were going to be in each group, and we didn't know whether each variable was going to be used. Once you get those 2 facts, once you get those 2 concepts straight, and you realize the things that you don't know in this game, I actually don't think the game is that bad. Hopefully you agree with me, and any questions that you have or had are been clarified by this video. Okay, see you in the next one.